Hello. In this video, I'm going to show you how I create mechanisms and more specifically two-axis positioner, which looks something like this when we are done with it. So the issue at hand is, or the background story is that a colleague asked for support with creating such a turntable which can tilt and rotate. So you have this rotational plate here and it can also tilt. So if we take a look at the agenda here in our trusty Paint, so I will cover how to create the mechanism from scratch and a couple of steps that I will show you, like recommendation, always work with the mechanisms in a new Robot Studio instance and empty station, and use ABB libraries as a reference when possible. So rotation and placement and frames, rotation of frames, for example. Rename parts of the mechanism for easier recognition. We will remove CAD geometries for future, like performance issues in the future. If you have a big station with many mechanisms and robots and whatever, it's nice to just try to limit the computational requirements for Robot Studio by reducing the CAD geometries. We will set local origin of each part of the mechanism to 0 before we create the mechanism out of it. Then I will configure an external axis. So this turntable, it will be a part of the system. And yeah, that's pretty much it. Actually, there's one more thing that I'm going to cover, and that's how to swap mechanical unit joints in the controller versus the mechanism joints. This will be more clear when I go over the steps. So let's go back into the Robot Studio software here, and I'll just remove the finished mechanism and just start from scratch. Let's see here. This is the one that I received from the colleague, and I can straight off the bat see here that there's a couple of issues with it. And this is where the recommendation compared to or use a ABB library as reference comes into mind. If you just look at the position of the two-axis positioner that ABB provides and compare it with the mechanism that is created here, you can instantly see that there are some differences. For example, this axis, the tilt axis, it rotates around the y-axis on the created mechanism, whereas on the ABB one, it rotates around the x-axis. And if we take a look at the frames here, the attachment frames, you can see that this one is basically the same as the world frame, whereas on the ABB one, it's actually turned, rotated 180 degrees around the z-axis. So if you want to have a mechanism that works properly with the controller as an external axis, you should follow the libraries. Like you have to create a copy basically of the position and rotation of the ABB mechanism or the library here. So let's just make it invisible for now. And then I'm going to, so right now I'm working in an empty station. You can say it's, there are no systems in the station and just these two things. What I usually do when I already get a created mechanism is that I go to modify mechanism, and then you can see all of the parts which it's made out of. And then I just press close, and then I hit Control Z, or you can use this, the undo hotkey here. Then I get all of the parts out of the compiled mechanism here. And then I can just remove the old mechanism and just work with the parts. So if we take a look at these parts, so this is the top part, I guess, and then we have the base and we have the tilt mechanism, or tilt part, I guess. So what I usually do is I go into modify and just remove CAD geometry on everything, just because it's unnecessary for Robot Studio to like include them in calculations. It just creates extra load. I see that they created the target here. It's not necessary. I don't know. Yeah. Is it not possible to remove it? So I can't really figure out why this frame is there. It seems like it shows up when you create this, or when you remove the CAD geometry, it shows up. So let's see if we can do some magic to remove it in another way. So we basically join these items into one, create a part, which is the whole thing there, steal the name from this, remove it, then we rename this one into the old name, and we remove CAD geometry. So now we have three parts which make up the whole item. Then I like to rename things so that I recognize them in the mechanism creation window later. So this will be the, I guess we can call it top plate, for example. This is the tilt, yeah, just like so, and the base. Okay, so now we should try to place this thing so that it looks similar to how the ABB library is placed. So we should rise it up, and we should rotate it, what is it, 90 degrees. So let's take a look at how we do that. Modify, no, position, offset position, and we want to move it up in the z-axis, but how much? So we will use our measuring tool, and let's see here. Right, so if we just measure, for example, from the center of this circle, which lies on the floor, and the bottom part here, we have a number here, 413.5 in the Z. So that's the distance we have to move all of these parts in. Position, offset position, 413.5. Apply. And so looks to be in the correct position now. Then we rotate it around the Z. Is it minus 90 perhaps? Nope. All right, so it was plus 90. And now you can see that it's starting to resemble the ABB library one, where the turntable is right under the other turntable, and we have the tilt mechanisms facing the same direction in the negative x-axis. Then we can continue. Well, all right, I would like to just rotate the not the tilt but the top plate a little bit, because you see it's a bit weirdly offset. So just I don't know how many degrees. All right, I think this, or no, one more. Maybe it's not possible to get it completely straight. Well, anyway, now it looks okay. And then when we moved all the parts, now we have to set the local origin to 0 on all the parts. And why do we have to do this? It's because when the mechanism is created or compiled, the tool itself will translate, like create calculations where everything is put in a proper position, but basically just to verify that everything, the mechanism will be in this location after we've compiled it into a mechanism. So this is one way to just guarantee that that will be the case. So I just set local origin to 0 on all parts, sorry, on all fields XYZ plus the rotation and XYZ to 0. And yeah, from here on, we can continue to create the mechanism itself. So there's one thing that is a bit a nifty trick. You can create a frame and you can position it in the same position as the attachment frame on the ABB library frame, and this frame can then be used as a reference when you create the attachment frame for your custom mechanism. So let's have a look. All right, so it got created, but you see that the rotation of it is wrong, so we can rotate it around Z 90 degrees. So now I believe that it's the same as the attachment frame. No, actually, I think it's still 90 degrees wrong. So let's flip it to 90 more. Right, here we go. Now the attachment frame on the ABB robot, or the positioner there, is the same as this frame. Now we can hide the library, and then we can go on and create the mechanism. So let's name this 2-axis positioner. Yeah, like so. It will be an external axis. And then we go into links. I always start with link 1, base. So here you can see why I renamed the parts in the station. It's much easier to just find the proper parts without having to look for it and so on, to just convenience. So link 1 is base, link 2 can be the tilt, link 3 will be the top plate. like so. Now you can see them here. And then we continue and create the joints. So the first joint, it's between the base and the tilt mechanism, so it's a rotational joint. And how do we find where it's supposed to be placed? I usually just make this one invisible, or actually no, let's do it the other way. Make this one visible and um, the base maybe, yeah, like so. You see this circle here, then you can select the I guess what is it, the center finder tool here in RoboStudio. Click here, click there, and then click there again, and then you have like a 1 point, well, if we create a direction in the along the x-axis, you can see the green line going through the whole parts, because it begins at this position and ends at this position. It becomes a vector which goes along the x-axis. I think that the limits are fine. Now you can test it and you can see that it actually tilts. And then you can press apply. We can make it visible again, the base. So now this is the swivel, the plate. And let's see if we can do something similar here. So if we make it invisible, then we can place the first position in the center, the second position too, and this one will rotate around the z-axis. And it doesn't really matter if you put -1 here or 1, because it's just a vector direction, so it will always go like around this around the z-axis. And this is supposed to rotate -720 plus 720. And how do I know this? It's because I just do. That's the the previous one had these numbers. That's why I know it. And then we can make it visible. Oh yeah, if you want to test it, you can see that, yeah, it looks like it's turning properly. And we continue to create the frame. I usually want to call it tool 0, or you can call it attachment frame or something like that. And it's supposed to belong to link 3 because that's the rotational plate. And we will want to have a position. Yeah, this is where you can use the frame that we created before. If we select values from target frame, and I guess we can target it, and so, but the issue here is that it's a bit offset from the plate itself, so I will just use it as a reference to remind myself, okay, how is it supposed to be oriented, you know, like negative x compared to the world. So anyway, I place it there. Okay, but I have to rotate it to 180 degrees. So now it looks just like the frame I created before. Okay, and then we continue to the calibration, and we just place them in the same location as the attachment frame, but we don't rotate them. We have to create 2 calibration frames for this positioner. And so we can now compile the mechanism. And we can close it. We don't need this frame anymore. All right. So now we have created the mechanism, and if we jog each axis, you can see that there's the tilt. I guess, okay, it doesn't really need to tilt 180 degrees, could be enough with 90, I guess. And then we can rotate the turntable here. Right, so where were we? Okay, so now we would like to have this mechanism be controlled by a controller. So I'll just pop in a random robot, let's say this one. Okay. We can remove the old positioner. Let's see here, offset position. Let's put it -500, something like so. This part is not necessary, it's just I just do it for the looks. And then we create a system from layout, robotware 611, uncheck the created mechanism, press finish, and we will wait a little bit. Okay, so the system has loaded up, and now we will go and use the external access wizard to add the external access to the system. And the external access is available through add-ins. If you search for external access, you have this add-in here, and it's the latest version. You can just select the version there. All right, so back to Home tab, External Access Wizard, and we check both of these robots here, or yeah, mechanisms. And we select some motor unit, whichever you need. I just select the random one because it doesn't really matter for this for my purposes. We go next, yeah, and just finish. Now we have to wait again a little bit. And when the controller restarted, now this mechanism is part of the system. So if we go into controller and we go to flex pendant, there will be some naming error because, yeah, I just it's a bad name. You should call it something else, I guess. We go to jogging, we select manual mode, and we select the positioner, and now you can see that we have the two axes here. And if we press down, the turntable rotates. If we press left here and right, the tilt mechanism works. And so there's one other thing. If you, for example, would like the first axis on the controller to rotate the turntable and the second one to do the tilting mechanism, this is possible if you go to motion configuration, you go to the positioner that you created, you click the change button here, and you basically flip these around. Apply and OK. And I believe you have to warm start the controller for this to work. Then bring up the flex pendant, and let's see here. All right, manual mode. So now you see that the first axis is no longer the tilt, but it's the turn table, the plate, top plate that flips, turns. And the second one is the tilt instead. Okay, so I think that covers everything I wanted to show you. Have a nice day.